My laboratory is a vestibular laboratory looking at balance function and also ocular motor function, so how eye movements help us stabilize the world and balance ourselves as we move through the world. When I came here, I first was intrigued by how eye movement deficits that we see in people with central vision loss might translate themselves to the kind of eye movements that are required by the vestibular system to stabilize our gaze. And so I was interested in how people who are known to have ocular motor deficits because they have central visual field loss, how those deficits may or may not translate to deficits in vestibular function. And so that's the first line of research that we do, is looking at what strategies people with macular degeneration and related central visual field loss disorders use to stabilize their gaze in the world as they move in all kinds of different ways. By virtue of being a lab that's interested in eye movements and head movements and overall mobility, that's really been a focus of ours, is to try to understand how we can better track eye movements in people with ocular motor disorders, but also in a variety of ecologically valid applications. We even came up with a validation tool, an eye movement robot that allows us to test different assumptions for different eye tracking devices out there and say, is what we're getting what we expect to be getting, given that this person doesn't have the same kind of gaze that people who the device was developed for have. That's also a part of our research that's not an explicit goal, but something that we are fallen into as an area of expertise for us that we've really enjoyed. This could be useful in a variety of ways. If you're a clinician and you're trying to use an eye tracker in the clinic, we might be able to help you, or you might use some of the research that we've done to say, okay, can I really trust this eye tracker when it's telling me that this person is making really small eye movements when I expect them to make bigger eye movements? Is that really true? As a clinician, that's something that would be very valuable to know. As somebody who's building that device, it would be great if there was more dialogue between labs like ours and them, and also the people who will use the device, like whether it's clinicians or, again, people like us, in terms of what are the needs, what are the different assumptions that can and cannot be met, and also best design practices, not only for young college students or young engineers, but also a variety of patient populations or other people who may have unexpected ocular motor behaviors. In this age of rapidly changing and rapidly evolving technology, when people with sensory loss can really benefit as the technology is growing and improving, it's really important to consider all aspects of what that technology means. When people develop different devices, whether it's a head-mounted display that improves contrast sensitivity, or a telescopic lens, or something like a retinal prosthesis that is limited by how big it can be on the retina or what kind of computational power it might have, there are important considerations to be made. Anything from how heavy is it, how hot does it get, all these different things, to something like, in the case of the telescopic lens or a retinal prosthesis, what is the magnifying power, what is the field of view, and how is a person receiving this kind of aid able to cope with the kind of magnification that they're receiving? Are their eye movements adjusted properly as they move their head through the world and looking at an eye chart, or sitting still and trying to watch their TV? And maybe that's enough, but it's important to consider what are the applications that something can and cannot be used for. I'm finding that because there's not enough dialogue between the industry partners that make these devices, between people who actually have to wear these devices, between scientists who study the vision aspect of it, but also scientists who think more about head movements, postural control, eye movements in the context of head movements and postural control. And when that dialogue isn't there, the devices tend to be optimized along one or another dimension, but not holistically to serve the person in every way. And so it's important for all of us, scientists, engineers, industry, clinicians who may be recommending the devices, to work together to really understand how we're optimizing this device, not only for the specific function, but also not to affect, not to damage other functions that people may need to have good quality of life and a safe way to interact with their environment. The devices and the therapies that are being developed oftentimes are created in a bit of a vacuum, and involving different partners, including researchers like us and also people who might be using these devices, would be beneficial for the clinicians that use the device, but also the companies that develop the device. All of these groups could benefit from improved dialogue between researchers like ourselves and these other partners.